explaining all my lines of code. This first part is just simply importing the libraries that I need and saving it as an alias. The first one is importing the Pandas library and saving it as an alias PD so that I'm able to, whenever I call PD, I'm able to access all the functions in the Pandas library. And I imported NumPy and I saved it as NP. The next line of code, what the next line of code does is just to read the CSV using the .read underscore CSV function. What this function does is just helping us to be able to read the CSV by passing the path. So I copied the path because I saved the CSV file to this folder called sample data. And then I just copied the path where I have this CSV saved and I pass that path to the read underscore CSV function so that I'll be able to read the CSV. And I saved it as a variable named my DF. So my DF now becomes my data frame so that anytime I call my DF, I'm referring to the data frame. And then the next line of code uses the .head function. What the .head function does is just to print out the first 5 rows of this data frame. And as you can see, I wanted to just print out the first 5 rows. And here we have as our output, the first 5 rows of this data frame. The next line of code is I want to assign some column names to this data frame. So what I do is I made a makeshift data frame so that I'm able to manipulate or do whatever I want to do here. So my makeshift data frame, I saved it in a variable named df underscore preview. And what I want to do first is I want to first read the CSV. So I pass the path to the function read underscore CSV. And then I also pass the number of rows I want to read. So I want to read the first 5 rows. So, and then I saved this into df underscore preview. The next line of code is because I want to make sure that this data frame has these column names. I save these column names as a list in expected underscore columns variable so that I'm able to call it later and make my comparison. ID, range, value, machine type, and zip code are the names of the columns. Now I want to check if the first row contains the expected columns. Well, I'm going to be using an if statement here. So first of all, I called if list, the list of df underscore preview does columns. So I'm calling this data frame, all the columns in the data frame. That's what I'm just doing. I'm calling it out as a list. So if I'm calling it out as a list because I want to compare this list that I have created, the second list I have created is what I expect to see in the columns. So what I'm saying is if the expected columns are not found in this list of columns from my data frame, that's what the if statement signifies. What do I do? So when I don't find it, what I'm saying in the next line of code is we have to read, first of all, we read our CSV. We read the CSV, and the next line of the next thing I pass to this function of read underscore CSV is header equals to none, which I'm trying to say that do not treat the first row as headers. Rather, because I'm not treating the first row as headers, I want to manually input my expected columns. So what I'm doing here is I'm giving the column names, and then I'm giving the column names by passing the list of the expected columns, which is ID, range, value, machine type, and zip code, which this will arrange this column name sequentially for me as columns because I have not found the expected columns in the data frame. So this is what I'll do if this condition is met. Now, if this condition is met, meaning that if this condition is not met, meaning that I have found the expected columns in the df underscore preview dot columns. That means they are equal. The column names and my makeshift data frame columns are the same. So that means I don't need to do anything. What I need to do, the main data frame, I just read the main data frame. And the next line of code, what it does is, am I saying that I'm going to save this? I'm just going to say, this is my df dot to CSV. Am I saving it? I'm just going to look at this CSV, but I am not, index equals to false means that I am not saving it. Now, the next thing to do is I just want to print out the first 5 rows and look at what is going on. So I printed the first 5 rows of the main data frame. Now, on this number 4, it's just like loading the data frame again. So I'm just loading the test01.csv. I'm loading it into the variable my df again. And I just loaded it and then I just printed the head. I use the .head function to print out the first five rows of this data frame. And then the next thing I'm doing here is I want to read the data sets. I'm skipping the first row. And as I have said, when we say head and none, what we mean is that do not treat the first row as headers. Do not treat the first row as headers. So why we're doing this is because we want to manually input the expected columns as our first row. So what we did first is we used the main data frame. We are reading our CSV using the read underscore CSV. We've passed the path. We're saying skip the first row. Do not consider the first row as, not treat the first row as headers. Now assign the correct columns by, we save the expected columns in a variable called expected columns, which we saved the columns that we want, ID, range, value, machine type, and zip code. After saving it, what we're saying now we're going to call all the columns from the data frame my df. So we've called all the column frames and just automatically assigned what we want to see, the expected columns in this sequence: ID, range, value, machine type, and zip code. This is what we want to see from the data frame. So we are saying that my df.columns, which is the columns of the data frame, will be equals to these expected columns. So it just replaces whatever the columns are, the previous columns were, is it just replaces it with these new expected columns, and then I use the .head function to check what is going on. As you can see, my output shows that I have displayed ID, range, value, machine type, and zip code, which are the new column names that have been assigned to the columns. It's just printing out the data types. So we're using, anytime we call D types, what it does for us is just print out the data types of the columns. So all the data types of all the columns are being printed out when we run this code. Now, the seventh one is, we want to find out which of these codes, is more object oriented, and we want to print out the we're going to say, well, first of all, we're going to store the data frame, this column. We want to print out the column actually, but want to store it in a variable so that we can actually print out the column. We can always call it. So that's, a very good way to represent things in like the object-oriented format. Now, this second code does the same thing, but the shortcoming of this second code is that if, for instance, your column name has a space, this will not be able to work. For instance, a column name that has machine type, you're not able to call my df.machine type in this. So it will only work for, most times, a column name that just has it just has a value like this, not one that has like 2 words and with a space. So this is what like you want to print out the column, you want to print out everything in the column, you can use this code to do that. Now, to determine the data type of a value column, we have said before that you can use the D type. So in this place, we can save it as a variable. This is an object-oriented way, and then
we're calling this column here, and we're saying that we should print out the data type of this column. So the next line of code, what it just does is print out a string saying that the type of my value, the type of the value column is, we're calling value type, value the type, which we have saved here. So we have saved it here and we're calling it now. So what is going to give us is the data type. Now the ninth code, what it does is, um, first of all, we want to save a zip code column into, we're calling a, we're saving a variable named zip code underscore column. We're saving the column name zip code in this variable, and then we're printing it out. That's just all we did here. Now, we're checking whether this zip code, if we had used the dot zip code, if it will work. Like I had previously mentioned, that as long as we have a space in the column name, this dot, column name will not work out. So that's why the first one is the one that will work. The second one will give an error. On the 10th one, what we want to do is to create a new column brand. We want to combine machine type and zip code. So now what we did was we called the data frame, and then we passed this brand. Brand is the name of, that's what we want to call the new column. So what we did is use concatenation. So we concatenated these two columns, machine type and zip code, to form a new column named brand. So what it does, it takes in the values of machine type and zip code and adds it together. As you can see down here, it has added the values of machine type and zip codes to form a new column with values as machine type and zip code added together. Now we're creating a new column here by combining the product of range and value. So for this one, we're going to use the operator function, which multiplies the value of range and value. And then we're going to use, what would our new column name will be total. So just like we did in the previous one, we called the data frame, we gave it the column, the new column. So we're saying that this new column should be equals to the value of the range times the value of value. So that's what is going to give us total, which total is the new column name. So the values here are multiplying range and value. Now for the next line, what are these codes representing? These ones that have brackets, parentheses, are methods, while the rest of them are attributes. That's what's the difference between these ones that have parentheses and these ones that do not have parentheses. The rest of them are attributes. So on line 13, what does the describe method do? The describe method will just show you the summary statistics of columns. For instance, it shows you count, it shows you mean, and etc. If we want to create a new data frame with the ID column renamed without modifying the original data frame, what we do here is, for instance, we're going to save a renamed, we'll call it a renamed underscore df, which is just a variable name that we just picked arbitrarily. So now what we're doing, we're calling the rename function. What we're passing into the rename function is the old name of the column, and we're now passing the new name of what we want to call this column. So we're actually changing ID to my ID. When we say in place false, we're just saying that don't save it to the real or the original data frame. That's what we're just saying. Then we display the first 5 rows of this column so that you're able to see, what you have done. But in this position, or in this place, we have not saved this. We did not save this into the original data frame. So it's going to show you the same thing that you had, which is going to, that means it's showing you ID because you didn't save it into the data frame. Now, if we rename this ID column to my ID, we're just doing exactly the same thing that we did, but this time around we're saving. That's why we use in place equals to true here. That means we're saving it to the original data frame. And then we're doing this now. We're now going to print out using the head function which prints out the first 5 rows, and we're seeing that our ID column has been changed to my ID, and it is being shown in the original data frame because we saved it with in place equals to true. Now on 16, what we just did was display our column names by using dot columns to print out our columns, the names of our columns. So this, it just shows you, it just prints out the names of our columns to list. Now on 17, what we want to do now, we want to rename our columns. So first of all, we just say my df dot columns. What we did was renaming these. The previous names of the columns were in capitals, so what we did was put them in lowercase letters. So by just putting it, arranging it the way it's supposed to be, or the way you want to see it, it just follows sequentially. So we just arranged it in a list called ID range value, etc., in a way that it will replace the previous column names. So see, when we print out the updated column names, what happens? It just shows us the updated column names in a list. Now we're replacing spaces in the column names with underscores. So uh df dot columns, what we're doing now, we're calling these columns now, and we're saying that these columns replace, we're passing two things into this function. What we're passing, the first thing we're passing is, we're passing that anywhere you see a space, replace it with an underscore. That's what we're saying here. So the second thing that was passed here is what is going to be a replacement. So this string dot replace, what it does, it is replacing whatever you have told it to replace here. It replaces it with this in the columns. That's what because we call columns first. So in the columns is replacing it, and it's saving it to my df dot columns. Now if we print it out, and we see that we have replaced these ones that have, like, machine type previously had a space, we have replaced it with an underscore. Now on 19, we're permanently deleting the brand and total columns. So the dot drop function, what it does is it drops the columns that you want it to drop. So you indicate in this you indicate in the parentheses what are the columns that you want to drop. So we're saying that drop these columns, and we say columns equals to brand and total. So we're dropping brand and total. In place equals to true. We're saying save it to the original data set and print out the first 5 rows for us to see. Line of code does is, we're using the drop function. What the drop function does is it deletes whatever you put in the parenthesis. So now on this one, we're passing two arguments. So the first one we're going to pass to the drop function is, we're telling it to delete indexes. We're using the index 3 and 5. We're deleting index 3 and 5, and the in place function, the in place true, which we have put here, is just saying that when you delete it, save it to the original data frame. So after doing this, the indexes will be, of course, when you have deleted rows 3 and 5, indexes will be showing like 0, 1, 2. It will skip 3 and then to go to 4, and leaves our indexes not organized. So in order to make it more organized and better, we are going to be resetting the indexes. So we're resetting the indexes with using this function reset underscore index. What it does is it resets the index. When we say drop is equals to true, at this point what we're saying is that discard the old index. Discard the old index, because since it's like 0, 1, 2, 4 or whatever, discard the old index. And when we discard the old index, instead of keeping them that way, discard the old index values instead of keeping them in the way it is at this time. And then the in place true, of course, saves it to the data set. Now we display the first 5 rows with the dots head function, which will just give you the first 5 rows, and is showing that the indexes are now well arranged. If we were to print this were to print this just before we did the reset, we would have seen that the indexes would be like 0, 1, 2. It will skip 3, and so it will be like 0, 1, 2, 4. So this code, what this code does now here is to sort the value column by ascending order and display only the value column. So how we do this is we're just saving this. This is an arbitrary, the name is just arbitrary, sorted underscore value dot column that we picked to represent. We want to save whatever we're doing here so that we are able to print it here. So what do we do here? We're going to call the column value from our data frame, which is my DF, and we're going to use the sort underscore values function. And the sort underscore values function, what is in the parentheses is how we want to sort it. And when we say ascending through, means that we should sort it in an ascending order. So we have called the value, which is a column, and we're saying sort these values in ascending order, and let me see what you have sorted. We just saved it in this variable so that we're able to print out this variable and see what we have done or how we have sorted these values. Now, on 22, we are going to sort the values in sort the data frame values in ascending order again. So in this way now we are using the sort underscore values directly on the data frame. So we're not like saving it in, like in this previous one we saved it in a variable. This one, we're calling directly our data frame and we're using the underscore sort values. Then we are calling it by value. That's we're calling it by the name of the column. And ascending through means that we want to sort it in an ascending order. And we're printing out my DF, which is going to print out how we have sorted it out. It just prints out our data frame, how we sorted it out because we called it directly and then we sorted the values. We didn't have to save it in a variable. So now what this one does is we're doing the same thing that we just did in the previous number, but this time around, when we say in place equals true, as I previously said, is that we're actually saving this to the data frame. So when we print this out, when we display this, we see what we have done because we saved it to the data frame. So we see what we have done here. We see what we have done. So the next line of code, what it does is it arranges the DF first by ascending order. When it arranges the range, we arrange the data frame by the range in ascending order. We also want to arrange the value in descending order. So how we do this is we still call the data frame and then we use the sort underscore values, which helps us to sort our data frame, and we're passing the range and value. Now, this one will pass the range and value. We're also telling it ascending. We're trying to say which of them, because we have range and value, which is going to be corresponding to true and whether it's going to be ascending or descending, it will be corresponding to these values are corresponding to these columns. So for instance, the range value here, we're saying, are we going to use, are we going to sort it in ascending order? We stay true here. For the value, now the value column, are we going to sort this column values in an ascending order? No. So we're actually sorting it in a descending order, and the in place true is that we're actually saving it to the data frame. And then we print out this data frame when we have sorted the range in ascending order and the value in descending order for us to see here. The next one now, we filtered this data frame. So we're displaying the rows where the value is between 250 and 350. How we do this is we're going to save what we're going to call in a variable, and we just picked the name of the variable as filtered underscore df. Now what we're doing is we're calling the data frame. When we call the data frame, we're saying that the data frame, the range in the data frame, which is the column name in the data frame. We're looking for values of this range which are greater than or equals to 250. And these values of the data frame, the range values of data frame have to be less than or equals to 350. This will invariably give us the values between the values for range between 250 and 350. So those are the values we're calling. Since we saved it in a variable, so we can actually print out the variable, and we're going to get the columns where the range is from 250 to 350. Now, on 26, what we want to do, we want to display the rows where the values is 250 and 350, just as we had displayed before. But this time, we want to sort the values by the range. So when we want to sort the values by the range, we're sorting the values by, what we mean is we're sorting the values by the column range. And then we are doing, when we say ascending through, means that we are sorting it in an ascending order. So we have called we've called the data frame, we've picked the column from the data frame, dot sort underscore values, as I previously said, sorts are the values that we are getting. So we will sort the values, and then what we're sorting the values by is by our column. We ensure to put what we're sorting the values by, and we ensure to put how we are sorting the values, which we have put that ascending is true, meaning that is in an ascending order. Because we have saved it in this variable, we print out the variable name here, and we are able to see the filtered values that we want. Now, for this one, we want to sort this one. We want to display only the ID and value for columns where the range is between 250 and 350. So we have done this before in the previous example. What we did was searching for values that the range is between 250 and 350. So what we did is we called the data frame, we called the column in that data frame, which is this range. We're looking for values greater than or equals to 250 and values that are less than or equals to 350. So this will give us values between 250 and 350. Now, what we want to do is we just want to print out the ID and value columns for the values whose range differ from 250 to 350. So in essence, we don't want to print out the range. We want to know the values that have the range from 250 to 350, but we want to print out the ID, the corresponding ID and values. That's why we had first of all filtered this data for these values, and we're saying print out ID and value. So we stored it in this variable called filtered underscore rows underscore df, and we printed it out here. For 28, what we want to do here is we want to we've already filtered, just like in a previous example, we have filtered rows where the range is between 250 and 350. And then we also want to add another condition. So we're using this and here. We're using this and here because we're adding another condition. So another condition is we're calling the data frame, and we're saying look for places where our machine type, which is the column machine type, is equals to H. That is equivalent to H, the string H. So wherever we see the string H in our machine type, so we're also looking for, we have to ensure that the values are between the values of the range are between 250 and 350, and the machine type that we're looking for is H. When these conditions are met, we're saying we don't want to print out just range and these values. What we want to print out are these values here, the values of these columns: ID, value, and machine type. So when we have satisfied these, which is what we're filtering, we filter the values for range in this the range that we have given to it. We also make sure that machine type is equals to H. Then we print out the corresponding ID, value, and machine type in this way. As we can see, results here are printing out only for machine type H for that range. Now, this other one, we're going to be using the is-in function. The is-in function, what it does is it checks this column, because we are calling here, we have called the data frame, and then we've called the column in the data frame, and we are checking whether these strings H, arrow, or X are in the values of the machine type. So we check where we have in this column machine type, where the values H, arrow, or X exist. That's why we're using that's what the is in function does for us to check. So when it checks, we have saved whatever it has checked. Now we've saved it in the filtered machine. So we're going to be printing out the my df, because what we did here is we called the whole data frame. So we're saying print out the whole data frame for which HRX appears in the column machine type. So we saved it in this variable name, and then we printed out the variable name. That's why it's printing out the whole data frame for us, but it's just printing out the data frame for which this condition is satisfied. Then the last one is we're displaying the data types of all the columns. So I previously said that the .d types, what it does is it prints out the data types of the column that we're telling it to print out. For this case, we are saying print out the data types of our data frame, which we had previously saved as my DF. So just this code only says that we have put in a string here to say data types, just for clarity. Data types of all columns with would be my df dot d types, which would just give us, which would just show us the data types of all the columns. Now, if we want to print out like numerical columns, we just saved it as a variable so that we are able to call it to print out on the other line. So what we did was we we used the select underscore d types function, which we had to pass something in here. What we passed is for the columns that are numbers, which are numerical columns. So for the columns that are numbers, save it as numerical underscore column underscore df and display the results. This one was just for clarity to say that numerical columns is like just shows or prints out numerical all the numerical columns